Okay, so question 1 was saying, given that x minus 4 is a factor of this function, and that the division of the function by x plus 2 leaves a remainder of 18, find the value of a and b. So we also know that x plus 2, when it divides into this, leaves a remainder of 18. Okay, so let's get to the answer. The first, I'm going to use the factor and remainder theorem. They're very similar, but we'll use them both here. The factor theorem is if I sub in 4 into this, my remainder will be 0. So that's because it is a factor. This x plus 2 isn't a factor because it leaves you with a remainder. That's hence why we have to use the remainder theorem for that one. So factor theorem, x equals 4 can be subbed into that function. So the function with 4 in it is 4 cubed minus 2 times 4 squared plus a times 4 plus b. And now we know that equals 0. Okay, because it is a factor. When I multiply all that out, I will get 64, take away 32 plus 4a plus b equals 0. Now I'm very happy with this because I get an equation in a and b equals minus 32, I think, if you rearrange it. So that's one equation, 2 unknowns. Now if I get a second equation on 2 unknowns, I can solve them simultaneously. And that's where the remainder theorem can come in. So it's pretty much the same deal. If I sub in minus 2, I will get a remainder of 18. So that's what I'll do. I'll sub in minus 2 cubed, minus 2 times minus 2 squared, just replacing x with minus 2. Plus the b gives me not 0 because it's not a factor, gives me the remainder 18. Difference between factor theorem and remainder theorem, pretty much the same. All right, if I do all this out, minus 8, then okay, minus 2 squared, that's minus 8 again. Minus 2a plus b is equal to 18. This is looking like I'll have two nice equations that will be easy to solve simultaneously. That's going to be minus plus 16 over this side. So that's 34. Okay, so here's my two equations. So we should be able to solve simultaneous equations in our sleep, but I'll do it very quickly for you. I'm going to take the first equation and I'm going to take the second equation, but multiply it by 2. That's this one by 2. So I get minus 4a plus 2b and 64. No, 68. Double it. That goes, so we've got 3b is equal to 36, and b then will be 12 from that. Once I know b is 12, I can sub into either equation. So 4a plus 12 now instead of 4a plus b equals negative 32. So 4a then has to be negative 44. A is negative 11. And that's the answer for the first one.
Sir, I did a simple arithmetic mistake.
Okay, well, that would only be a maximum of, so that'd be a 6 mark probably, or 5 mark question. Simple arithmetic mistake probably loses you 1 or 2 depending on the mark scheme and depending on what it is. Okay, so it's a 6 mark question. So 6 marks means approximately 7 minutes to do it. Okay, question 2 then. So another given factor, 3x minus 2 is a factor of this. X cubed plus 23x squared minus 33x plus 10. They want to fully factorize the polynomial. So there's a number of ways of doing this. Number of ways. You could divide in, and then you get a quadratic. You can use, you can substitute in, use the factor theorem, and get 0, and oh, that will help. No, that will only prove this factor. You can't do that. Well, you could, but I don't think it would help us. So find the other 2 roots is the question. Or find, no, it's not. What's the question? Fully factorize. Okay, so that means you need it into its 3 linear factors. Okay. So that's 1 linear. We need 2 more of those brackets to finish the question. What I'm going to do is I'm going to say that this factor multiplied by some quadratic equation is going to be equal to this. And then I'm going to equate the coefficients of each term. So what's the sum quadratic equation? Well, x squared, it's not going to be x squared because 3x times this has to give that first term. So it's going to be actually 2x squared because 3x times 2x squared gives 6x cubed for the first term. I'm going to do the exact same thing to find the last term. Plus 10 is made from minus 2 times what? Well, it'd have to be minus 5 for the last term. Minus 2 times minus 5 gives that plus 10. So I'm setting up just needing to find this middle term. I'm going to call that, well, I don't know what it is, so I'll just call it A. That's the term. That's the key. All right, so if I multiply this by 3x and then this by minus 2, I know that my product here should be the exact same as this, but it'll have A in it, but that's okay. So I get 6x cubed, which doesn't really matter. Didn't have to do that, but I'll do it anyway. Plus, make sure I get these 3ax squared and minus 15x. Now multiplying by minus 2, I get minus 4x squared minus 2ax. If you do see a mistake, just shout. Plus 10. Combining, all right. I know, okay, so 6x cubed is the same as 6x cubed, no problem there. And plus 10 is the same as plus 10 there. This all bit in the middle must equal this bit in the middle for it to be the same polynomial. The x squared coefficients of plus 3a, so just looking at x squared, plus 3a, so just 3a, and minus 4 should equal whatever the coefficient up here was. That was equals 23. Okay? So solving that very quickly, add 4 to both sides. And I get 3a is equal to 27. That means a must be 9. Now I can test out again 15. I can do the same for the other coefficient, but I need to find a once. If I'm quite confident that I have it, I'll get it. Let's just check. 15, 2a, 33. So if a is 9, minus 18, and minus 15. Yeah, okay, it's going to work for that as well. So all good in the hood. Let's then finish it off. So I have 3x minus 2, and I have 2x squared plus 9x now minus 5. And that is going to, I can factorize that to finish. So I get 2x, and I get x, and I get 5, and I get 1. And I'm going to need plus 5 and minus 1. And that's it, fully factorized.
So don't we also don't we also have to do like x equals -5 and all that, or did the question not ask?
No, that's for the factors. They're factors. Factors are what multiplies to give its polynomial. So not the roots. You didn't have to do any more than that. You could have, but it was
Yeah. So I got the same answer, but I used long division, so that's also right.
Yeah.
Right.
Yeah. Okay. So
Okay.
question 3 then. P of x is a real polynomial of degree 5. That means it has x to the power 5 in it. If I wanted to do that, I don't think I need it. With leading coefficient 1. So x equals 1. Hold on a second. I just must close the door.
Can I bring her in?
Okay, sorry about that. Crying baby. All right. All right, we're dealing with this polynomial that has a degree 5 with leading coefficient 1. Zeros. Okay, it's got plenty of zeros. Show that. Okay, the graph. Okay, loads of information here. Loads of information. So we have zeros. Zeros of this polynomial are m plus 2i, m minus 2i, 1 plus mi, 1 minus mi, and 2. All right, so that's all its zeros. Awesome. M is a real number. It's given in the question. And the polynomial cuts the y-axis at negative 56. All right. Show that m is plus or minus root 3. All right. So what does this tell us? This, I'm just building this up as I go along. This is the constant at the end. Okay. This is the constant at the end. I also know that the leading term, if I were to multiply it out, x5, x to the power 5, has a 1 in front of it. This is telling me that it's going to have something to do with sum and product of the roots. If they're giving me this information and the last term information, that's all about sum and product of the roots, isn't it? Because I know the product of the roots then is going to be minus 56 divided by 1. So it's our old chestnut, a to the power of 0, not a to the power of 0, a0, an, and minus 1 to the power of n. Remember that product of the roots, if we use that, because that's the last term divided by the first term and minus 1 to the power of many terms there are. So that's actually going to give us the product of the roots in this case is, well, it's going to be, minus 56 is a0. Oops. Minus 56, that's a0. Minus 1 to the power of n is minus 1 to the power of 5. There's 5 terms, tells us that. And a to the n is going to be 1, the coefficient of the first term. That's very convenient. So the product of the roots then is, well, minus 1 to the power of 5 is minus 1, times minus 56 is plus 56. So plus 56 is the product of the roots. What does that tell me? That tells me if I multiply all these zeros together, I'm going to get 56. And when I do multiply that, the only variable is m. I is not a variable. I is a known number. So the only variable is m. So I should get an equation in just m. So let's do that. 0, 1 is 2. Multiply by m plus 2i. Multiply by m minus 2i. Multiply by 1 plus mi. Multiply by 1 minus mi. This is the product of the roots, and I know that now equals 56 based on the initial work I did. Okay. All right, so the easiest two to multiply are these two and these two, because they are difference of 2 squared. So that means it's going to be m squared. The middle two terms will cancel out as usual, and we're left with minus 4i squared from this one. So 2i times 2i. And this one's going to be 1, and I'm going to get minus m squared I squared from that one, m squared I squared. And still times 2. This I can tidy up because I know I squared equals minus 1. I always have that in my locker to use for I squared, and that'll still equals 56 from before. But the I squareds are going to go. So I get 2 times, you could have jumped to this line if you're quick, m squared plus 4. And 1 plus m squared equals 56. Okay, not quite multiplied it all out, but nearly there. I'm going to now multiply it all out. So 2 times, well, m squared times that. M squared times 1 gives m squared. M squared times m squared gives m4. So that's the first bracket by the second, or the first term by the second bracket. 4 now times these two. 4 times 1 gives 4. 4 times m squared gives 4m squared. And that equals 56. Okay, let's combine the like terms here in the brackets and then multiply by 2. So I've only m to the power of 4. So I'm going to multiply by that by 2. Oh, actually, do you know what I'll do? Instead of multiplying all these terms by 2, I'm just going to divide both sides by 2. I think that might be easier. Because that just makes this 28. 56. That's easier. So now I'm just got m4 plus 5m squared plus 4 equals 28. I think that made it easier for us. This is a quartic, but it's a quartic in kind of form of quadratic, which means it can be factorized a bit like a quadratic, because this is actually, that's actually m squared squared, and that's plus 5 also m squared plus, oh, it's not going to be plus 4 now. If I subtract the 28, I get minus 24 equals to 0. So I'm setting it up like a quadratic equation. In other words, that's x squared plus 5x minus 24. So let's factorize that. I'm just going to do it over here on the side. So it's going to be m squared and m squared. Factor is a 24. I'm going to use 8 and 3 plus and minus because I'm looking to get plus 5 in the middle. That means m squared is going to be negative 8 from this one, or m squared is going to be 3. Now, which one do I select and which one do I dismiss? This one is automatically dismissed because it's going to be the square root of minus number. It's going to be a complex number. Now, normally I would have to include that, but in the question it says m is real. It says that. So I must go with this one. And you're also asked to show that it equals this. So if m squared equals 3, m equals plus or minus root 3. And that is it shown. Okay. Second question. Second part of the question. Okay, so we have... so we're looking for the x4 coefficient, which would be the second coefficient in this original thing that we didn't know. We're looking at x4. Now, what we know about x4 is the coefficient of 8 divided by the first one minus is going to be the sum of the roots. So all we need to do now is add all the roots. Okay, add all the roots. I call the coefficient a. So let's go back to this, or b, or whatever. Let's call that a plus a. So the sum of the roots is going to be minus a over 1. So just minus a. So, and then if I find what a is, I'm good to go. That's an a. So I'm going to add up all the roots. 2 plus, well, m can either be plus root 3 or minus root 3. Let's go plus root 3. I think it'll make our life easier. You will get the same answer if you use minus root 3, but because it could be either, and either would satisfy. So I'm just going to use plus because plus is always easier to use than a negative. And I'm just what I'm doing is I've replaced all the m's with root 3, and I'm just going to add them, and that's it then. And that now equals minus a from up here. That's the sum of the roots. And if I get what a is, that means I have the coefficient. Okay. Adding all these bits up together. Let's add up. Oh, yeah, the imaginary bits, plus 2i minus 2i, and these are going to cancel. So that makes it a lot easier. There's a root 3 here, and there's another plus root 3 here. So that's 2 root 3 anyway. And I've got 2. That's gone, that's gone, it's gone. 2 plus 1. I think it's 4, is it? 4. 4 plus 2 root 3 is equal to negative a. So that means a, which we want to find. Remember, it's a, not negative a. A then would be the opposite sign to that. Minus 4 minus 2 root 3, and that's the answer. Okay.
Wait, sir, isn't there 2 answers?
Is there 2 answers? What if I find?
It's plus or m can be plus or minus for.
Would I get the same answer? Minus 3, minus root 3. Oh no, I wouldn't, would I? You're right, Rigel. Thank you. I'll have to do it again with minus root 3 to get a second answer. Ugh. Okay, do it again with minus root 3.
Okay.
Same thing, and I imagine just the sign here changes, does it? It's going to be...
The second one does. It's just plus. Yeah.
Okay, yeah. Oh, yeah, so you did have to do it twice. You don't get the same answer. So, yeah, you wouldn't get the same answer. I don't know what I was thinking. Yeah. So, yeah. So you're saying I'll check that, but yeah, I presume it's going to be something like that for the other answer for A. So it could be two. It's actually two possible coefficients that would give the same zeros. Okay. Cool. That's a question mark. I'll check that for sure, but that one's definitely right. All right, moving on to question 4. Oh, a proof. How did you get on with this one? Okay. Alpha, beta are two roots of this thing. Plus bx plus c equals 0. They are two roots. That's a new question. And prove, okay, that alpha times beta is a root of, oh, not the same one, is a different one, x cubed minus bx squared plus acx minus c squared equals 0. Okay. So if this is a root, it means if we replaced x, I should get 0. So in other words, alpha beta, because it is a root by the factor theorem, alpha beta cubed minus b times alpha beta squared plus ac times alpha beta minus c squared equals 0. So if it is a root, that should equal 0. Okay, so if I can prove that all this equals 0, then I'm happy. So how am I going to get B, A, and C? Well, I can get it from this first one. And then I'll have only equation alpha and beta, hopefully. And then they'll all cancel out. That's what I'm hoping. And all cancel. In other words, all this side will equal 0, and that side equals 0, and that's what's proved. So I have to use this equation, really. So if they are the roots, that means I can say that x minus alpha times x minus beta times, well, this is a question. What's the third root? We're not entirely sure. Let's call it A, B. We've used A, B, C, D. You could use gamma. Let's use P. Just random letter. Still don't know what it is. But I know when I multiply all these out, it has to be the same as this, which is going to give me okay, there's going to be P, but we might be able to deal with that because the constant term is nice to us. It'll get rid of A, B, and C and replace it with alpha, beta, and P. A, B, and C were gone. And that, when I say got rid of, I can have equivalents for A, B, and C that I can replace in here with just alpha, beta. And, well, let's see what happens with the P. Okay. So let's multiply all this out. That'd be x. I'm just going to do the first two. That's x squared minus alpha x minus beta x plus alpha beta, I think, times x minus p, which is actually, well, let's multiply it out and then I'll take the like terms together. So multiplying all this by x first, I get x cubed minus alpha x squared minus beta x squared plus alpha beta x. And then I'm going to multiply it all by minus p x squared minus alpha p x. No, plus alpha px, because it's minus p times minus, plus beta px minus p times alpha beta, or whatever order you want to put it in. I may have mixed up my orders there, but possibly p should come after alpha beta. Okay, it doesn't matter. It's multiplication is commutative. Doesn't matter what order we do it. Now, at least now, once again, I can equate coefficients here. I know the coefficients of this must be the same as this. So I can say for the x squareds that this a up here is the same as minus alpha minus beta. Looking for another x squared. Oh, that's it. Let's just make sure I haven't made a mistake here. Minus p. Oh, I have made a mistake. Minus p times x is minus p times that first term. I didn't actually do it. It's not minus p squared. It's minus p x squared. So that's also minus p there. So that's all the x squareds. I think that one. Yeah. Okay. Let's do the x terms. Their coefficients must be the same, and they must equal b from up here. B equals alpha beta. Alpha px, is that correct? Yes, it is. Plus alpha p plus beta p from this one. Okay. And then the constants, I'll just say CON for constants. C has to be equal to each other as well. So there only is one constant here at the end and one constant up here. So minus p alpha beta. Okay. So my goal here is to get this equation up here in just alpha beta if I can. I can put p's in it and it might cancel out. This b, I don't think I can cancel out the p. I'm going to have to put p in here as well, and hopefully it'll all cancel out. Let's do it. This is going to get messy. Let's just see, and hopefully we can finish it off nice and quickly. If it doesn't work out, I have to do a different route. But I think it will. It should, theoretically. Alpha beta cubed, which was up here. I'm just minus. Now b, I have something in alpha beta and p. So alpha beta plus alpha p plus beta p times alpha beta squared. Okay. And then I have a times c. Yuck. A times c is minus alpha minus beta minus p times c minus p alpha beta times alpha beta. And minus c squared is this, this squared, minus p alpha beta squared. Now, the idea is all this is going to equal 0. And if it all equals 0, then we have solved or proven. Hopefully it will. It's going to get messy though, but stay with me. Let's just keep alpha beta cubed out front here. Don't need to cube that out. I'm going to multiply alpha beta squared by all that. Alpha beta squared by alpha beta gives them, that minus in front gives a minus alpha beta cubed, which I'm slightly relieved at because then alpha beta cubes are gone. Now alpha beta squared times alpha p gives plus, no, it gives minus because that's minus in front, minus alpha squared beta p. Another minus term next, alpha cubed, isn't it? Alpha cubed here, because that's squared. Alpha beta times this is tricky. Alpha beta, just to get your algebra absolutely spot on, otherwise it won't all cancel out. That's going to be alpha beta cubed p. This has a look at difference, 2 squares about it, but we'll see. That's that multiplication done. So I've done that. Now I need to do this one. Multiply these two terms together first, and that's going to give me, let's just combine it here. That's going to give me minus p alpha beta squared. It's alpha beta times alpha beta. So I'm going to multiply that by each of these terms. So I get plus alpha cubed beta squared p. I get plus alpha squared beta cubed p. I get plus p squared alpha beta squared. But then brackets don't, yeah, have to be in brackets, sorry, like that. And then I have plus p squared alpha beta squared here. If I want, I could have squared them all out, but I'm not entirely happy with my multiplication, but I'm hoping some of it works out anyway. That's gone. That's okay. There's so many alpha betas here. Can I factorize the whole thing by alpha beta? Possibly. You're not seeing that, sorry. Alpha beta and p. I can take alpha beta p out of all these terms, and possibly I should have done that before I even multiplied. Let's take out a negative alpha beta p out of all these. No, let's leave it as positive. Alpha beta p out of all these terms. So this one just leaves me with alpha squared minus alpha squared. Out of this one, it leaves me with minus beta squared. Out of this one, it leaves me with plus alpha squared beta. Out of this one, it leaves me with plus alpha beta squared. Out of this one, it leaves me with p alpha beta. Now this one, it leaves me with p alpha beta equals 0. This is not working out for me. This is not working out for me. Okay, well, I'm not going to waste any more time on this one. I'll figure it out and tell you tomorrow. But this is the method. I've obviously made some mistake with signs here, or some multiplication mistake because I try to do it all at once. Possibly, I think earlier on here, I possibly should have found that p was equal to something. P is equal to c over alpha beta, or minus c over alpha beta. I think that would have helped me, just having c in this equation instead of this thing, which was a bit messy, and c being the unknown, not p. And that might have helped me a lot because c is multiplied here, multiplied here, and having an answer for p instead of c would have worked nicer. Did anyone get this out?
No, but at the beginning, I mean, I used the first thing to find c, if the product of roots with the first one. So you just get the alpha beta equals negative c.
Yeah, it would, wouldn't it? Alpha beta would equal negative c. That would be a good move as well.
I tried to go from there, but then
yeah, maybe try that one again to this evening, gents. You can see my method. There's a number of methods, as Rai just said, looking at that first equation. Alpha times beta is equal to negative c, is it? Does it?
Yeah, that's what I got.
Yeah, alpha beta equals negative c. That would be another string to your bow. Perhaps you could substitute in there and get c in this thing. I know that. Maybe I could change that to c, and then I know what p is minus c over alpha. Maybe it will all cancel out. Maybe it'll all cancel out. Even maybe I've done it right. I just haven't. I need to factorize this, and it'll work out nicely. Perhaps it will. Not sure. I think I made a small mistake with a sign or something somewhere in this, but you get the idea. So the idea was that alpha beta is if it is a root, all this when it multiplies out will equal 0. So you can replace beta b, a, c. I put in p. You don't have, if you want to use, you don't have to use p if you want. You can try and find an alternate method like Rigel was doing, using alpha beta is equal to negative c. So do something and try and get left-hand side 0 equals 0. And I think that's definitely the method you should use, I think, for this one. But I'll have a little look at it and try and fix it for tomorrow anyway. I don't want to do too much more on that. I'll look at what you guys did as well before tomorrow so we can see where we're going around. All right, just going to finish off today with something called odd and even functions. Okay, and odd and even functions have it has a lot to do with symmetry. So if I look at, let's look at x squared, so fx, a function, equals x squared, and a function of x cubed. Let's look at those two functions very quickly in sketches. If x squared is this nice little u shape to it, okay, and x cubed, the parent function, it looks something like this. It will flip here and go on off like that. It looks something like that, I think. So it tends to infinity both these directions. Cool. This one, infinity, infinity. All right. So what can I say about x squared? I can say that it is, well, it's symmetrical, isn't it? About the y-axis. In other words, it folds nicely over the y-axis. Its graph folds over the y-axis. So what's interesting about that? Well, that means that if I want to find my value for when x is 2, so the function when x is 2, I get out a value of, well, 2 squared is 4. Now, if I want to find the value of minus 2, I also get 4 out. Minus 2, I also get 4 out. So what does that say? That says that for any value of x, if I put in its negative value of x, I get the same answer out. That will continue the whole process. If I put in 3 and negative 3, I'm going to get the same answer out the whole process because of that symmetry. We looked at that complex numbers and you'd have a plus minus. So it's symmetrical. And this thing, when it's done like this, so a squared equation like this, is called an even function. And we can test for an even function by that reflection in the x-axis, y-axis, not x-axis. Okay, so that means anything that has that reflection. So that's x squared, x4s, x6. So you're probably noticing the pattern. If there's an even power with the x, that's they share this trait. They share this trait of even. It's called an even function, and it's a reflection in the y-axis. So that means the other one I must have drawn must be an odd function. X cubed is an odd function. But what's the relation? It's not. It can't be a reflection. This doesn't reflect there. It doesn't reflect in the x-axis either because it would look like that. So what's its key? Well, let's look at the same thing we did before. What's f of 2? F of 2 of this function, well, if I sub in 2 cubed, gives 8. F of minus 2, if I sub minus 2 into this function, it actually gives negative 8. Okay, so what can I conclude? So normally you wouldn't, of course, jump to a conclusion for all functions like this based off just one result. But you can try it and it does work. So for odd functions, if I sub in the, so if I look at what I have above, when I subbed in f of 2, write that again. When I subbed in f of 2, it didn't equal f of minus 2. It did not equal, these don't equal each other. But if I make this negative, if I get the function with 2 put in it, and I just made the answer negative, I do get the same answer. So I can say in general, f of negative f of x is equal to f of negative x. And that's for an odd function. So if I need to switch the sign of the positive input to match the negative input, it's an odd function. Now, it's not a reflection. Does anyone know what type of transformational relationship it has?
So what do you mean by translation?
No, so so you're looking at what's the relationship between these two numbers. It wouldn't translate. No, not translate to get from that point to that point. That would still look like itself.
Wouldn't any value for when you plug in for f of 2, 3, 4, 5 just be the resultant of like a negative number? Like f of 5 will be an integer, a positive integer, and the negative will just be the exact same but negative?
Yeah, so that's what we're saying. So if you sub in it's positive, you get the same as if you subbed in it's negative, but you'll have to change its sign. It's not the same. You'll get negative at the end. One would be negative the other. It's actually a rotation.
Yeah, 180 degrees.
Yeah, about 0, 0. So the function has a rotational symmetry. So if you rotated this, it would line up on itself again, wouldn't it? Rotated. So if you rotated it around, it would end up, if 180 degrees, as Rigel says, about this point, it would end up back at back on itself. And if you want to test that, we can just trace it. So trace it. So, and if I just do my point here and I rotate it, oh, my page is getting caught. Rotate it, so that's a 90-degree rotation nearly. That's a 180-degree rotation. My page is still caught. Oh, I made a mess. I did it. I promise. You saw it. 180-degree rotation. I should have used a smaller page. I was getting caught. Okay. Well, what you need to know then is that x cubed, x5, x7, odd, you see the odd powers here, are all odd functions, even functions, odd functions. So we've looked at what makes them odd and even is technically the power here. And what's the properties of that? You can see that even functions, then substitution in of the opposite sign will lead to the same result. In an odd function, it will lead to the opposite integer. Yeah. So not all functions are odd and even, but some can be classified that are interesting, such as cos and sine. Now I don't know if you, and tan. You can look at those. Maybe you look at them tomorrow. Did you come across those functions? You should have come across them last year. Hopefully you did. Did you? The way they look, you know, the wavy one. Yeah. Hopefully you saw that last year. Anyway, I think we're run out of time on this. So what I would get you to look at chapter 6 and just do section A. Just have a look at section A. Section A on those odd and even functions before tomorrow, and try question 4 from our exam again, if you've time. Okay, I'm not sending any particular homework because we're due tomorrow, but if you've time, do both those. Look through section A, see some questions, and if any problems, we'll come tomorrow.
So what page is section A in?
Sorry?
What page is section A in?
Page 152. Okay, I'll have a look at your stuff and I will I'll give you some feedback tomorrow on what you did. And